History books have long told a simple story about ancient sailors. For generations, scholars believed that Mediterranean seafaring was a cautious, late-born art. They pictured early mariners nervously hugging the coastline, their fragile wooden ships never daring to lose sight of land. This was the established timeline, a comfortable narrative built from evidence found in shallow waters and on shore. But that story contains a profound mystery. How did legendary civilizations like the Minoans and Mycenaeans build vast trading empires and cultural networks if their ships could not brave the open sea? The very foundations of their power seem to crumble without the ability to navigate the deep. Today, that mystery is being solved not by digging in the dirt, but by diving into the abyss. A silent revolution is underway, led by deep-sea submersibles and robotic explorers. These machines are our eyes in the eternal darkness, and they are retrieving secrets that force us to rewrite history. By the end of this exploration, you will understand how treasures from the ocean floor are completely redrawing the map of ancient human connection. What we are finding suggests those ancient mariners were far more daring and capable than we ever dreamed. Their ships ventured into the deep blue, following routes we thought impossible for their time. What does courage look like when you cannot see the shore? For centuries, that timeline seemed perfectly logical, built from the evidence we could easily reach. The story began with the very first seafarers of the Neolithic period, perhaps as early as 12,000 years ago. These pioneers did not have ships. They likely used simple rafts or dugout canoes, venturing short distances between islands they could still see from one shore to the next. This was island hopping in the most literal sense, a cautious expansion motivated by necessity, not exploration. The archaeological record on land supported this. We found their tools on islands like Cyprus, proving they arrived, but the assumption was they came in short, manageable leaps. As millennia passed, boat-building technology evolved. By the Bronze Age, the era of the Minoans and Mycenaeans, ships were certainly more advanced. Yet the scholarly consensus held firm. These vessels, often depicted in beautiful frescoes, were seen as elegant but fragile. They were thought to be primarily oar-powered, with a single square sail useful only for running before a favorable wind. Their hulls, stitched together with rope rather than nailed, were believed too flexible to withstand the punishing waves and winds of the open Mediterranean. So the narrative crystallized. Bronze Age mariners were coastal navigators. They sailed from headland to headland, always keeping land in sight as a safety line. Their long-distance trade, it was argued, must have occurred through a slow chain of coastal exchanges, goods passing from one port to the next like a relay race, never carried directly across the deep. This entire model was built on a specific type of evidence, the kind that survives on dry land or in shallow, protected waters. Archaeologists studied harbor ruins, analyzed pottery styles that spread between coastal settlements, and examined the few shipwrecks found in bays or close to shore. These shallow wrecks, while invaluable, were by their very location proof of coastal activity. It was a classic case of the streetlight effect. You only look for your lost keys under the lamppost because that is where the light is good. For maritime archaeology, the lamppost was the coastline. The profound darkness of the deep sea, where the real secrets of long-distance voyaging might lie, remained an unexplored mystery. The traditional timeline was not wrong, but it was incomplete, shaped entirely by the limits of our own vision. That profound darkness is no longer a barrier. A quiet technological revolution has given us new eyes to see into the abyss, transforming the deep sea from an archaeological void into a library of lost history. For decades, underwater exploration was limited by human lungs and the crushing pressure of the deep. scuba divers could only work for minutes at shallow sites, and crude dredging methods often destroyed more than they revealed. The continental shelf, that gently sloping underwater extension of the land, was our frontier. Beyond its edge, where the seafloor plunges into the deep basin, history was presumed lost forever. That assumption has been shattered by a new generation of robotic and crewed explorers. The real game changers are machines like remotely operated vehicles, or ROVs. Think of them as underwater drones, tethered to a mothership by a long cable that carries power and data. Piloted by technicians in a warm, dry control room on the surface, an ROV can descend for hours, its robotic arms manipulated with surgeon-like precision to recover a single pottery shard from the silt. Then there are autonomous underwater vehicles, AUVs, which are like underwater satellites. They fly pre-programmed grid patterns over vast swaths of seafloor, using sonar to create breathtakingly detailed maps of the bottom, revealing anomalies that could be a ship's cargo or a natural rock formation. And for the most delicate work, we have crewed submersibles. These are deep diving pods like the famous Alvin that carry scientists right down to the site. Inside, they have a direct human view of history resting in the stillness, allowing for on-the-spot decisions that a remote pilot might miss. This suite of technology does three things we could never do before. It locates objects in thousands of meters of water with pinpoint accuracy. It maps entire sites in stunning detail without disturbing a single grain of sediment. And most importantly, it excavates with a gentleness that preserves context, the sacred relationship between objects that tells the true story. The deep seafloor, it turns out, is an extraordinary preservative. In the cold, dark, oxygen-poor environment beyond the shelf, wood does not rot quickly. Ceramics can lie undisturbed for millennia. A shipwreck, there is not a scattered debris field pounded by waves and eaten by worms, but a time capsule frozen in the moment of its loss. These machines have turned the deepest parts of the Mediterranean from a blank space on our historical map into a place brimming with clues. Every dive is a potential rewrite, a chance to find the one object that proves a direct connection across the open sea. The deep seafloor is not a barren wasteland but a silent museum. Its environment creates the perfect conditions for preservation, conditions that simply do not exist in the sunlit shallows closer to shore. This is the fundamental reason why deep-sea discoveries are so revolutionary. They give us a different kind of evidence, one that corrects a bias built into the archaeological record. In shallow coastal waters, a shipwreck faces constant assault. Sunlight fuels the growth of wood-boring organisms like shipworms that can reduce a mighty hull to Swiss cheese in just a few years. Waves and currents scatter artifacts, grinding them against rocks and sand. Oxygen in the water accelerates decay. In this active, destructive zone, only the most durable materials endure. We find amphorae, the ceramic jars used for trade, and stone anchors. But the ship itself, its wooden hull, its woven ropes, the baskets, the food supplies, the personal belongings of the crew, all of it vanishes. Our picture of ancient seafaring, therefore, was constructed almost entirely from pottery and stone. It is like trying to understand a modern cargo ship by studying only the steel containers it carried, while the entire vessel has disappeared. You can guess where it was going and what it traded, but you know nothing of how it was built, how it was sailed, or the daily life on board. Now descend beyond the continental shelf into the deep basin. Here a profound change occurs. Sunlight vanishes, creating perpetual darkness. The water temperature drops to just a few degrees above freezing. And most critically, in many areas, the water becomes anoxic, meaning it contains little to no dissolved oxygen. In this cold, dark, oxygen-poor environment, the processes of decay slow to a near standstill. Wooden planks can lie on the sediment for thousands of years, their shape and tool marks still visible. Ropes may retain their twist. Even organic remains like foodstuffs or the resin used to seal amphorae can be preserved. A deep-sea wreck is not a debris field. It is a moment frozen in time, a sealed capsule holding the complete story of a voyage, from the engineering of the ship to the diet of its sailors. For the first time, we are not just finding what these ancient people traded, we are finding how they lived and journeyed. This preserved organic evidence is the key that unlocks the true sophistication of their maritime technology, evidence that was literally rotting away in the shallows, forever lost to the old timeline. The first crack in that comfortable coastal model appeared not in the abyss, but in a deceptive stretch of open water. In the mid-1970s, off the small Greek island of Dokos, a discovery was made that sent quiet ripples through the world of archaeology. A local sponge diver named Dimitris Kontos reported seeing what looked like a field of broken pottery on the seabed. This was not a deep-sea find by today's standards, resting at a depth of about 120 feet. But its location was the key. Dokos sits in a channel between larger islands, exposed to the open Aegean Sea. This was not a protected bay or a hugging-the-coast kind of place. For a ship to sink here meant it was traversing a significant maritime route, a crossing that required confidence and skill. When archaeologists finally investigated, they uncovered the oldest known shipwreck in the world, a site now dated to around 2,200 years before the Common Era. That places it squarely in the early Hellenic period, long before the rise of the Minoan palaces. The cargo was a simple one, a massive pile of pottery, mostly utilitarian bowls and jars. There was no gold, no bronze, nothing conventionally glamorous. Yet this humble assemblage was revolutionary. The sheer volume of identical pottery suggested it was a cargo shipment, not just a local fisherman's lost goods. This was evidence of organized trade, of production for export, happening over open water nearly a millennium earlier than the sophisticated Minoan network was supposed to have begun. The Dokos wreck was a whisper from the deep, a hint that the story we had written was missing entire chapters. It proved that even in an era we considered technologically simple, people were building vessels sturdy enough to carry tonnage across open stretches of sea, connecting communities and economies in ways we had not dared to credit them with. This single site forced a fundamental question. If this was happening in 2200, what else were we missing from even earlier times, and what might have been possible later, in the darkness far beyond the continental shelf? The whispers from Dokos grew into a thunderous declaration with the discovery of two shipwrecks that would forever change our understanding of the Bronze Age world. Off the rugged southern coast of Turkey, the sea revealed its greatest secrets yet, not in the abyssal plain, but on steep underwater slopes at depths just beyond the easy reach of early scuba divers. These were the wrecks at Cape Gelidonya and most spectacularly at Uluburun, dated to around 1300 years before the Common Era, at the height of late Bronze Age power. These were not the ships of coastal peddlers. They were floating warehouses of globalized trade, and their cargo lists read like a map of the ancient Mediterranean and beyond. The Uluburun ship was a revelation. Its hull contained 10 tons of copper ingots from Cyprus, the island that gave copper its name. Alongside them were tin ingots, likely from distant Afghanistan, the two metals needed to forge bronze. There was raw glass from Mesopotamia, ebony wood from Nubia, ostrich eggshells and ivory from Africa, and pottery from Canaan, Cyprus, and Mycenaean Greece. Here was a single vessel carrying the raw materials of empire, connecting continents in one daring voyage. This was not trade by slow coastal relay. This was direct, long-distance maritime logistics on a staggering scale. The Cape Gelidonya wreck, slightly older, told a similar story of a metals trader, its cargo also pointing to a professional merchant class operating across open water. These finds were undeniable proof that Bronze Age mariners possessed the ships, the navigation skills, and the commercial networks to sail across the eastern Mediterranean's open seas. They forced archaeologists to accept that the Mycenaeans, Hittites, and Egyptians were linked by a vibrant maritime highway. Yet, in the wake of this stunning proof, a new cautious narrative emerged. Scholars began to view the Uluburun as a spectacular exception, a royal shipment or a one-in-a-million voyage. The sheer richness and diversity of its cargo seemed too extraordinary to be routine. The paradigm shifted, but only partway. The deep, open water crossing was confirmed, but it was placed in a category of its own, a rare feat of elite enterprise rather than evidence of a common, widespread practice. The ship was a floating palace of trade, but did its existence mean regular merchants were doing the same? Or was it merely a glittering anomaly, a special dispatch that proved little about everyday seafaring? This question left a door open, a lingering doubt about how deeply this new knowledge should rewrite our history books. If such voyages were rare, then the old model of cautious coastal travel could still largely hold true. The truth, however, was waiting in a much darker place, where not even the most ambitious Bronze Age diver could ever venture. The question left by Uluburun was one of routine. Could we ever know if such voyages were common or merely royal exceptions? The answer would not come from another spectacular, singular wreck. It would come from the darkness itself in overwhelming numbers. A quantum leap in our understanding began not with a dive but with a sound. Researchers realized that to find history in the abyss, they first had to learn how to see in the dark. They turned to side-scan sonar, a technology that works like an underwater flashlight, but with sound waves. Towed behind a research vessel, the sonar emits pulses that fan out across the seafloor. When these pulses hit an object like an amphora or a pile of ingots, they bounce back. The returning echoes are then stitched together by computers to create a detailed, almost photographic image of the bottom. This allowed teams to survey vast, unexplored tracts of the deep Mediterranean, searching for the telltale shapes of human activity. The initial results were cautious, a few promising blips on a screen. But then came the autonomous underwater vehicles. These robotic explorers took the search to another level. An AUV could be programmed to fly a precise grid pattern a few meters above the seabed, its high-resolution sonar painting a map of stunning clarity. It was the difference between looking for a coin in a football field with a flashlight and having a satellite photograph of every blade of grass. Systematic surveys, often led by collaborative efforts like the Hellenic Centre for Marine Research and the Woods Hole Oceanographic Institution, began to focus on the deep basins, the maritime highways between major ancient centers. They targeted the routes between Crete and Cyprus and the Levantine coast. These were not coastal lanes. These were the direct, open water crossings of the ancient world, the deep blue deserts where no ship was supposed to venture. And there, in the crushing silence and eternal night, they found them, not one or two wrecks, dozens. The sonar maps revealed clusters of anomalies, and subsequent visits by remotely operated vehicles confirmed them as ancient shipwrecks, their cargoes of amphorae resting perfectly intact on the soft sediment. Each dot on the map was a data point, a pin in a historical chart, and together they formed an undeniable pattern. These ships were not lost close to home. They were found exactly where you would expect them if they were sailing the most efficient, most direct route between major ports. This was the statistical proof that shattered the last vestiges of the old model. The deep sea wrecks were not rare exceptions or royal flukes. They were the traffic. They represented the routine, regular, commercial voyages that fueled the Bronze Age and classical worlds. The Mediterranean deep was not an impassable barrier. It was a well-traveled superhighway, its lanes now illuminated by the gentle ping of sonar and the silent gaze of robots. But the most profound rewrite is happening for a civilization whose very identity was the sea. The Minoans of Crete have long been celebrated as history's first great maritime power, a thalassocracy whose influence rippled across the Aegean. Yet our understanding of how they achieved this was constrained by that old coastal model. We pictured their elegant ships with curved sails, depicted in vibrant frescoes, dancing between the visible peaks of Cycladic islands, a network built on a chain of short, safe hops. This view neatly contained their genius, making it impressive but understandable. The deep sea, however, tells a different, far more daring story. Recent surveys along the seafloor routes between Crete and the coasts of North Africa and the Levant have begun to reveal scattered traces of Minoan presence in the abyss. Isolated amphorae with distinctive Cretan shapes, fragments of pottery with familiar spiral motifs, these are not found in coastal shallows near a friendly port. They are found out in the profound blue, resting on sediment thousands of feet deep. These are not the remains of a shipwreck's main cargo, which would be a concentrated pile. These are likely single items lost overboard during a long voyage, what archaeologists call jetsam, and their location is a map. Each one is a tiny, silent marker on a highway across the open Mediterranean. Finding a Minoan pot hundreds of miles from Crete, in water so deep it could only have been lost from a vessel far from any shore, is like finding a modern soda can in the middle of an ocean crossing. It is proof of passage. This evidence suggests that as early as 2,000 years before the Common Era, perhaps even earlier, Minoan captains were not merely island hopping. They were setting a direct course for the rich ports of Egypt and the ancient Near East. They were navigating by the sun and stars, trusting their ship's construction to withstand days or weeks out of sight of land, driven by a desire for direct access to the sources of gold, ivory, and other prestige goods that fueled their sophisticated culture. This transforms the Minoan thalassocracy from a regional network into a truly trans-Mediterranean enterprise. It supports the legendary tales of their maritime mastery, not as myth, but as a technological and courageous reality. Theirs was not a realm bounded by the horizon, but one defined by the courage to sail beyond it. But if the Minoans were charting these deep blue highways, what about the civilization that history books explicitly credit with mastering them? We arrive at the great enigma of the Phoenicians. For centuries, they have been celebrated as the ancient world's first true deep-sea navigators, the legendary mariners who sailed beyond the Pillars of Hercules into the Atlantic, founding colonies like Carthage and trading for tin in distant Britain. Our traditional narrative paints them as the successors to Bronze Age powers, perfecting open water navigation in the early Iron Age, around the first millennium before the Common Era. They are the archetypal oceanic pioneers, yet the silent testimony of the deep seafloor is prompting a startling question. What if their story of mastery began even earlier? What if the Phoenicians were not just perfecting a practice, but inheriting and expanding upon a much older tradition of blue water sailing? The historical texts we rely on, written by Greeks and Romans like Herodotus, describe their incredible voyages, but these accounts come centuries after the fact. They are the legend, not the logbook. The physical proof of how and when they achieved this has been frustratingly scarce until now. Deep-sea archaeology is beginning to provide that proof, and it suggests a timeline that rewrites the opening chapter of their saga. The key evidence comes not from the famous Atlantic routes, but from the heart of the Mediterranean itself. In the deep basins between the Levantine coast, where their city-states like Tyre and Sidon thrived, and the central Mediterranean islands, robotic explorers are making finds that challenge the textbook sequence. Discoveries of shipwrecks in very deep water, dating to the 9th and even 10th centuries before the Common Era, are carrying distinctively Phoenician cargo. These are not coastal traders carrying local goods. These vessels are found on the direct, open sea routes to the west, laden with standardized amphorae for wine and oil, fine ceramics, and the iconic Phoenician purple dye made from murex shells. Their location is a map of intent. To sink in water thousands of feet deep, a ship must have been sailing a direct course, far from any shoreline refuge. This pushes the evidence for sophisticated, long-distance Phoenician maritime enterprise back by centuries, closer to the twilight of the Bronze Age collapse and the dawn of the Iron Age. It suggests that their famed nautical prowess was not a sudden Iron Age innovation, but a capability that was already highly developed, perhaps even inherited and refined from the network of sea routes already being used by others. The implications are profound. It means the Phoenician expansion westward, which shaped the entire cultural and economic landscape of the Mediterranean, was not a slow, cautious creep along the North African coast. It was from a very early stage a confident thrust across deep water. Their ships had to be more robust, their navigation methods more reliable, and their commercial vision more ambitious than we previously allotted to that era. Each deep-water wreck is a data point confirming that the Mediterranean was not a barrier to be feared, but a connective medium to be mastered. The Phoenicians did not invent the deep-sea crossing, but the evidence now suggests they industrialized it, turning ancient maritime highways into the superhighways of a new economic age. These deep-sea time capsules offer more than just proof of a voyage. They provide its exact biography. The extraordinary preservation of organic materials allows scientists to date a shipwreck with a precision that was once unimaginable, turning a cargo list into a detailed historical calendar. On land, archaeologists often date a site by the style of pottery found there, a method that can span centuries. But in the cold, dark deep, the story is written in the very grain of the wood and the residue in the jars. The most powerful tool is Dendrochronology, the study of tree rings. A wooden hull plank recovered from the deep is not just a piece of timber, it is a climate record. Each ring represents 1 year of the tree's life, with wider rings indicating good growing seasons and narrower rings indicating drought or hardship. Scientists have built master chronological sequences for different regions, like a fingerprint database for ancient forests. By matching the unique pattern of rings in a ship's plank to these master sequences, they can determine not only the year the tree was cut down, but often the specific forest where it grew. This gives a near-exact construction date for the vessel, sometimes pinpointing it to within a single year. It tells us if a ship was built from local oak or from timber imported from across the sea, revealing entire supply chains for shipbuilding. But the dating goes deeper. Inside those perfectly sealed amphorae, scientists now analyze microscopic organic residues. They can detect traces of wine, olive oil, fish sauce, or honey that evaporated millennia ago but left a chemical signature behind. By studying the compounds, they can sometimes identify the specific agricultural practices used, even the region where the grapes were grown. Furthermore, preserved food remains like fig seeds, olive pits, or nutshells can be radiocarbon dated independently, cross-referencing the timeline. This multi-layered analysis does more than give a date. It constructs a vivid snapshot. We can now know that a ship built from Anatolian pine in the spring of 1327 before the Common Era set sail from a Levantine port in the autumn, carrying jars of honey from Cyprus and wine from a specific Aegean island, only to be lost in a winter storm on a direct route to Egypt. This is not just chronology, it is a recovered moment, a ledger entry from the deep that connects ecology, economy, and human endeavor with stunning clarity. That recovered moment includes the most important artifact of all, the ship itself. For generations, our understanding of ancient naval architecture was a puzzle with most of its pieces missing. We had beautiful paintings on pottery, vivid frescoes in palaces, and written descriptions from later periods. We had a handful of scattered timbers from shallow coastal wrecks, often too damaged to tell the full story. From this, scholars made educated guesses about how these vessels were engineered, but it was like trying to reconstruct a modern airplane from a travel poster and a few rusted bolts. The deep sea has now delivered the missing blueprints, preserved in stunning detail. When a remotely operated vehicle's lights illuminate a hull section resting on the soft silt, it is not looking at a ghost. It is examining a masterclass in ancient engineering frozen in time. The cold, anoxic depths have saved from decay what centuries of scholarship could only theorize. We are seeing, for the first time, the actual craftsmanship that allowed these cultures to conquer the open sea. The evidence is no longer an inference. It is a direct instruction manual from the past. One of the most startling revelations comes from Bronze Age wrecks, like one found off the coast of Turkey. Here, archaeologists expected to see the simple, shell-based construction they had long hypothesized. This method, known as shell first, involves building the outer hull planks first and then inserting the internal framing. It was thought to be a primitive technique, resulting in a flexible but less sturdy vessel. What the deep-sea timbers revealed was far more advanced. They show clear evidence of a strong internal skeleton being built first, a framework of ribs and keel that gave the hull immense strength. This skeleton-first approach is the foundational principle of modern shipbuilding. To find it fully realized over 3,000 years ago forces a complete reassessment of Bronze Age technological sophistication. These were not flimsy boats. They were robust, engineered structures, their frames designed to withstand the relentless flexing and pounding of ocean waves. The joinery holding them together is equally sophisticated. We can now see complex mortise and tenon joints, where a projecting piece of wood from one plank is fitted tightly into a carved slot in the next, locked in place with wooden pegs. This created a hull that was not just nailed or sewn, but intricately interlocked, a wooden mosaic capable of holding its integrity under tremendous stress. Furthermore, the deep-sea preservation shows us their waterproofing secrets. We can analyze the exact composition of the resins and pitches used to seal the seams, often mixtures of pine tar and beeswax applied with meticulous care. Each of these details, from the grand framework to the microscopic dab of sealant, tells us that ancient shipwrights were not just artisans. They were applied physicists and material scientists, solving problems of hydrodynamics and structural integrity through generations of trial and error on the open water. This is the tangible proof behind their daring voyages. They did not cross the deep Mediterranean in spite of their technology. They crossed it because of it. The silent cargo of a ship tells its truest story. While amphorae and ingots offer proof of trade, the deep sea's perfect preservation reveals what was inside them, an invisible economy that has completely vanished from the historical record on land. For centuries, our picture of ancient commerce was built from durable objects, the ceramic shells that once held something precious. We knew they traded wine and oil because we found the jars. But what kind of wine, what quality of oil? Were they transporting exotic spices, rare nuts, or vibrant dyes? On land, these organic treasures decay into dust within years, leaving no trace for archaeologists to find. The deep-sea time capsule changes everything. Inside those sealed amphorae, resting in the cold dark, microscopic clues have waited for millennia. Advanced chemical analysis can now detect the faintest residues, the molecular ghosts of substances that evaporated long ago. In a deep-water wreck off the coast of Cyprus, scientists did not just find jars. They found the chemical signature of oregano and thyme, herbs packed with the wine to flavor it and perhaps mask spoilage. In another, traces of pine resin were detected, a common additive that acted as a preservative, giving the wine a distinct taste that historical texts describe. This is not just a list of goods, it is a recipe, a snapshot of ancient taste and preservation technology. but the revelations go far beyond seasonings. Some of the most stunning finds are traces of luxury. In a Phoenician wreck in the Western Mediterranean, researchers identified the chemical footprint of murex dye, the legendary Tyrian purple. This was not a shipment of finished purple cloth, which would be obvious. This was the raw, concentrated dye itself, a cargo of staggering value being transported in its most efficient form. A single gram could color the trim of a royal garment, and here was evidence of pounds of it crossing the open sea. Similarly, residues of precious incense, like frankincense from the Arabian Peninsula, have been identified. These substances left no physical remains on land sites, but their chemical fingerprints in deep sea jars prove that the trade in aromatics for ritual and elite use was a major maritime enterprise. Then there is the evidence of diet and agriculture. Preserved olive pits and fig seeds from deep wrecks are not just debris, they are data. By analyzing their DNA and shape, scientists can determine the specific cultivar, tracing an olive variety from a grove in Greece all the way to a ship lost near Italy. This reveals an astonishing level of agricultural specialization and targeted export. They were not just shipping generic olive oil, they were shipping a known product from a specific region, a Bronze Age equivalent of a protected designation of origin. Nutshells like those from almonds or pistachios tell a similar story of deliberate trade in foodstuffs that could survive a voyage. This invisible cargo rewrites economic history at its core. It shows that the ancient Mediterranean economy was not driven solely by bulk metals and pottery. It was sustained by a vibrant, sophisticated market for perishable luxuries and high-value additives that connected farmers, artisans, and consumers across vast distances. The deep sea proves they were trading in flavors, scents, colors, and tastes, building a world of sensory richness that we, until now, could only read about but never truly touch. Their ships were masterpieces of engineering, their cargo holds brimming with invisible luxuries, but none of it mattered without one critical skill, the art of finding a way across the featureless blue. This is the central puzzle of deep-sea seafaring. We have the proof they made these voyages, but how? In an age without magnetic compasses, without GPS, without even a reliable sea chart, how did a Bronze Age captain point his vessel toward a distant shore he could not see and trust he would arrive? The deep sea wrecks themselves provide the first, most powerful clue. Their location is a map of intent. A ship found resting on the seabed halfway between Crete and Egypt was not lost. It was on course, it was following a known path, a mental highway drawn not on parchment, but in the memory of the captain and the patterns of the natural world. These direct routes tell us their navigation was not guesswork. It was a sophisticated system, a blend of observation, inherited knowledge, and simple but brilliant tools. The primary guide was the sky. By night, they would have used the stars. Certain stars, like the North Star, Polaris, hold a nearly fixed position in the northern sky. While its exact alignment has shifted slightly over millennia, it still provided a constant northern reference. Other constellations, like the Great Bear, would have been used to mark the passage of time and direction. By day, the sun was their compass. They understood its arc across the sky, rising roughly in the east and setting in the west. With careful observation, a seasoned sailor could judge latitude, how far north or south they were, by noting the height of the sun at its highest daily point. A simple shadow-casting stick called a gnomon could have aided this. By measuring the length of the shadow at noon, they could gauge their position relative to familiar ports. But the sky alone was not enough. They were master readers of the sea itself. They possessed deep, generational knowledge of the Mediterranean's wind patterns, the seasonal adhesions that blow from the north in summer, providing reliable power for sails heading south to Egypt. They understood the major surface currents, great rivers within the sea that could speed a voyage or push a ship dangerously off course if not accounted for. This knowledge was likely passed down in song, story, and practical apprenticeship, a living database of maritime experience. For moments when the sky was hidden by cloud or storm, they had other tools. A lead line, a simple weight on a marked rope, was used for depth sounding. By measuring the depth and bringing up a sample of the seabed, sand, mud, or shells, a navigator could compare it to known coastal profiles, figuring out roughly where they were even without a sight of land. Birds flying toward shore at dusk could indicate the direction of land over the horizon. The color of the water, the types of floating seaweed, even the smell of the air carried on certain winds, all became data points. What the deep sea wrecks prove is that this system worked. It was not infallible, as the very existence of the wrecks attests. Storms, human error, or illness could doom a voyage. But the statistical pattern of ships found on efficient, direct routes tells us that successful crossings were the norm, not miraculous accidents. These sailors were not blindly courageous. They were precisely knowledgeable. They transformed a vast and intimidating ocean into a network of known paths, navigating by a complex living map written in the stars, the winds, and the waves. This navigational genius carved invisible highways across the open sea, and sometimes we find the precise spot where those highways converged. In 2015, a team of Greek and American archaeologists decided to survey a small, forgotten cluster of islands in the eastern Aegean known as the Fourni Archipelago. It was a test, a focused look at a place that was not particularly famous in the history books. The islands sat at a natural crossroads between major ancient trade routes, a potential pit stop, but no one expected what came next. Using side-scan sonar towed behind their research vessel, they began painting an acoustic picture of the seafloor around these rocky shores. The first few targets appeared, and divers went down to verify. They were wrecks, then more targets appeared, and more wrecks were confirmed. The numbers kept climbing in a breathtaking cascade. By the end of that first season, and in subsequent surveys, they had documented not 1 or 2 shipwrecks but 58. All within a concentrated area of just 17 square miles of seabed. This was not a deep-sea basin discovery. These wrecks rested at depths accessible to divers between 30 and 200 feet. Yet the Fourni project became a revolutionary case study, a microcosm of what the deep sea might hold on a colossal scale. The wrecks spanned an incredible timeline, from the archaic Greek period around 2,500 years ago through the classical and Roman eras and into the medieval period. Each ship was a timestamp, a single frame in a film that played for over a millennium. A Greek merchantman from the age of Pythagoras rested not far from a Roman vessel carrying amphorae from Italy, and a medieval Byzantine coaster lay nearby. This density was the key insight. The Fourni Archipelago was not a ship trap or a uniquely dangerous place. It was a bustling ancient service station. Ships traveling the major east-west and north-south routes would duck into its protected coves to wait out bad weather, take on fresh water, make repairs, or trade with local fishermen. The sheer number of wrecks found in such a tiny area proved this was a constant, churning hub of maritime traffic for centuries on end. It provided statistical, undeniable proof of the volume of ancient seafaring. If this many ships were lost in the safe shallows of a single archipelago, imagine the multiplier effect in the open sea. The project's co-director, Peter Campbell, put it simply. He said they found a wreck about every 4 days of diving, a rate unheard of in archaeology. Fourni offers a critical analogy. It is like discovering a single, incredibly busy intersection in a lost city. By studying the traffic patterns at that one crossroads, you can extrapolate the size and complexity of the entire metropolitan network that fed into it. The 58 wrecks are the tangible evidence of the highway. They tell us that the maritime traffic of the ancient world was not a trickle of occasional adventurers. It was a relentless, dense flow of commerce and communication, and if this many ships met their end in the relative safety of a coastal hub, the logical, staggering implication is that the deep basins along the direct routes between continents must hold orders of magnitude more undiscovered sites. Each of those deep-sea wrecks is a missing chapter, waiting in the dark to rewrite the story of a connected ancient world. Yet the greatest test of these maritime networks was not a storm, but a historical cataclysm. Around 1200 years before the Common Era, the glittering world of the Bronze Age imploded. The great palaces of the Mycenaeans and Hittites burned. The trading empires collapsed into silence. Historians have long described the centuries that followed as a Mediterranean Dark Age, a time of isolation, poverty, and cultural amnesia. The logic seemed unassailable. If the complex political and economic systems that organized long-distance trade had vanished, then the daring deep-sea voyages that depended on them must have vanished too. The highways of the sea, it was assumed, fell into disuse and were forgotten. This narrative of a broken network and a retreat to the safety of the coast became a cornerstone of our historical understanding. But the deep seafloor holds evidence that tells a different, more nuanced story. The darkness of the abyss reveals that the light of seafaring never fully went out. While the scale and grandeur of the Uluburun shipments may have faded, the practice of crossing open water did not cease. Recent discoveries are uncovering shipwrecks from this very transitional period, resting not in coastal shallows, but on the deep routes between surviving centers of power. These are not the grand treasure ships of pharaohs and kings. They are smaller, more modest vessels, but their location is the critical detail. A wreck dated to the 11th century before the Common Era, found in deep water between Cyprus and the Levantine coast, is a powerful testament. Its cargo might be simpler, perhaps a load of copper ingots and common pottery, but the fact that it undertook this open water journey at all is revolutionary. It means that in the wake of collapse, there were still captains who remembered the old star paths, still merchants who saw value in connecting scattered communities, and still shipwrights who knew how to build vessels capable of the voyage. This evidence challenges the idea of a clean break, a total reset of human knowledge. It suggests a thread of continuity, a fragile but unbroken line of maritime tradition that passed from the last Bronze Age sailors to the emerging cultures of the Iron Age. The networks may have contracted and transformed, but the knowledge of how to navigate the deep blue, the hard-won understanding of winds and currents, was preserved. It was kept alive in the memory of fishing families, in the designs of local boat builders, and in the daring of those who continued to look to the horizon. This deep-sea evidence reframes the so-called Dark Age not as an era of empty seas, but as a period of resilience and adaptation. The grand system was gone, but the fundamental human impulse to connect, to trade, and to explore across the water persisted. It was this enduring spark of maritime knowledge that would later be fanned into the brilliant flame of Phoenician and Greek expansion, proving that the ancient Mediterranean was never truly dark, only waiting for its next dawn. The resilience of those early mariners laid the foundation for a system of staggering ambition. When Rome rose to dominate the Mediterranean, it did not merely use the sea, it engineered it. The deep seafloor now offers us a ledger of that empire's true scale, revealing a maritime machine of precision and volume that rivals modern logistics. For the Romans, the Mediterranean was not just a highway, it was the central artery of their empire, and they pumped commerce through it with a systematic efficiency that left a permanent record in the abyss. The evidence comes in a familiar form, the humble amphora, but in numbers that defy imagination. Across the deep basins between Italy and North Africa, between Rome and Alexandria, robotic surveys are mapping what can only be described as ancient shipping lanes. These are not random scatterings of lost ships. They are clusters of wrecks found along the most direct, efficient routes between the empire's breadbaskets and its capital. Each wreck is a snapshot of a scheduled run, a cog in a vast economic system. The cargoes are telling in their uniformity. You find ship after ship carrying nearly identical cargoes of Spanish olive oil, transported in a standardized amphora known as a Dressel 20. Another lane is marked by ships laden with the distinctive, cylindrical amphorae from Crete, all filled with the same regional wine. This level of standardization is the signature of industrialized production and centralized distribution. It tells us that estates in southern Spain or vineyards on Greek islands were not producing for their local village. They were producing for a guaranteed market thousands of miles away, confident that the Roman maritime system would deliver their goods to the docks of Ostia. The most evocative of these standardized cargoes is garum, the fermented fish sauce that was the universal condiment of the Roman world. Wrecks in the Western Mediterranean have been found carrying hundreds of nearly identical amphorae, all sealed with the same type of stopper, all containing the residue of this pungent, prized sauce from factories in Portugal or North Africa. To find a ship loaded solely with garum sinking in deep water between Carthage and Rome is to find a floating piece of a supply chain. This was not a luxury item for the elite. It was a bulk commodity for the masses, shipped in volume across open sea because the demand in the capital was insatiable and the system to deliver it was reliable. The placement of these deep water wrecks is the final, conclusive proof. They are not found clinging to the coast in a long, cautious arc around the shoreline. They are found on the great circle routes, the straight lines drawn across the map. This means Roman captains, backed by the full knowledge of the state, were regularly embarking on voyages that would take them out of sight of land for days at a time. They were navigating by the stars and the sun, following established routes with known distances and seasonal schedules. These were not occasional, daring expeditions. They were the ancient equivalent of container ship routes, predictable, high volume, and essential to the empire's survival. The wine from Crete, the oil from Spain, the grain from Egypt, and the garum from Lusitania all moved on this deep water network. It was a system that turned the entire Mediterranean into a Roman lake, not just politically but logistically. Every amphora resting in the deep silt is a barcode from the ancient global economy, scanned by sonar and robots, telling us that the rhythm of empire was measured in the steady beat of oars and sails crossing the open blue. The amphorae tell a story of commerce, but the deep sea holds whispers of the people inside the ships. While trade goods reveal economic connections, other artifacts found in the abyss point to something more profound: the movement of human beings themselves across the open water. A ship is more than a floating warehouse. It is a capsule of daily life, and when one is lost in the deep, it preserves a moment of human journey with startling intimacy. Among the standardized cargo of a Roman wreck, archaeologists might find a small, personal oil lamp decorated with a unique symbol, a worn gaming die, or a simple cooking pot of a style not from the ship's port of origin, but from a distant homeland. These are not items for sale. They are belongings carried by individuals leaving one life for another. The discovery of diverse pottery styles on a single deep water wreck, for instance, can be a powerful clue. If a ship bound for the central Mediterranean carries not only its main cargo, but also a set of drinking cups from the Aegean and a few bowls from the Levant, it suggests a mixed crew or passengers from different regions, a microcosm of the Mediterranean's interconnected populations on the move. This evidence shifts our understanding of these voyages from purely transactional to deeply human. They were pathways for colonization, for the dispersal of families and entire communities seeking new homes, carrying their domestic wares and cultural tastes with them into the unknown. A deep sea wreck, therefore, can be an accidental time capsule of migration. its contents mapping not just trade routes, but the routes of human settlement and cultural blending that built the ancient world. The same open waters that served as highways for peace could also become arenas of conflict, and the deep seafloor bears silent witness to this danger. A ship found on a direct, deep water route with its cargo seemingly intact yet showing signs of a violent end presents a compelling mystery. Archaeologists look for clues beyond storm damage. The presence of weapons not typical for a merchant crew, like an abundance of spear points or sling stones scattered near the wreck site, can hint at a confrontation. More telling is the evidence of a hasty, desperate act. Imagine a cargo of valuable copper ingots, but instead of being neatly stacked in the hold, they are found scattered in a heap near a breached section of the hull, as if thrown overboard in a frantic attempt to lighten the ship during a chase or an attack. This is not the orderly loss of a storm, but the chaos of a fight for survival. In the ancient Mediterranean, piracy was a constant threat, and naval battles between competing powers shaped history. A deep-sea wreck could be the remains of a warship, identified by its construction, like a ramming prow, or a merchant vessel that fell victim to raiders. Finding such a site far from any coast underscores a grim reality. Conflict was not confined to the shoreline. The risks of piracy and warfare extended into the very heart of the maritime highways, making every open water crossing a potential gamble. This adds a layer of tension and courage to the story of ancient seafaring. It was not merely a technical challenge of navigation and shipbuilding, but a journey through a landscape where human threats could emerge from the horizon as suddenly as a squall. The deep sea thus archives not only the triumphs of connectivity but also its perils, reminding us that the waves connected destinies in ways both hopeful and tragic, carrying the dreams of settlers and the fears of merchants in equal measure. This partnership between the past and the present is not a one-way street. The robots and sonar do not tell their own story. They are the tools of a powerful symbiosis, a deep collaboration between two very different scientific worlds. On one side, you have oceanographers and engineers, masters of the deep. They are the ones who design the submersibles, program the autonomous vehicles, and interpret the shimmering sonar maps. They understand the physics of the water column, the chemistry of the sediments, and the immense pressures of the abyss. Their expertise is in reaching the unreachable. On the other side, you have the archaeologists, the interpreters of human history. They are the ones who can look at a scatter of amphorae on a screen and see a trade route. They can examine a sonar anomaly and recognize the distinctive outline of a ship's hull, even when it is buried. Their expertise is in asking the right questions of the past. Alone, neither group could rewrite the timeline of ancient seafaring. The oceanographers could find 1,000 wrecks but not understand their historical significance. The archaeologists could have brilliant theories about maritime networks but no way to test them in the deep. Together, they form a complete team. A mission begins with the oceanographers mapping a target area with meticulous grids of sonar, creating a detailed portrait of a landscape no human eye has ever seen. They guide the remotely operated vehicle with a pilot's precision, its robotic arms acting as extensions of the archaeologist's hands miles above. When an artifact is recovered, the roles blend. The oceanographer might analyze the sediment clinging to it to understand the environmental conditions when it sank, while the archaeologist identifies the pottery style to pinpoint its origin and date. This collaboration is now revealing more than just shipwrecks. It is uncovering the very landscapes the ancient sailors relied upon, using advanced sub-bottom profilers, which work like sonar but penetrate the seafloor. Teams are mapping ancient river deltas and coastlines that are now hundreds of feet underwater. At the end of the last ice age, as glaciers melted, sea levels rose dramatically, flooding vast stretches of the continental shelf. What was dry land 10,000 years ago is now the seabed. These submerged landscapes hold a key to navigation. A river mouth that once reached the sea was a natural harbor, a place for fresh water and shelter. A distinctive headland or a cluster of islands now beneath the waves would have been a major landmark for early mariners. By charting these lost features, the combined team can reconstruct the ancient coastline, understanding where safe havens and navigation points once existed. This allows archaeologists to model potential sailing routes with incredible accuracy. They can see that a direct course between two ancient ports would have passed right by a now drowned island, giving sailors a crucial mid-voyage reference point. It explains how those early journeys were possible. They were not sailing blindly into a featureless blue. They were following a mental map of a landscape that has since vanished beneath the waves, a map we are only now beginning to redraw through the shared language of technology and history. But this submerged library is fragile, and its pages are beginning to tear. The very technology that has opened the deep sea to discovery has also, inadvertently, exposed its secrets to new and profound threats. While ancient storms and the slow creep of time claimed these ships, a modern danger now looms, one that moves faster than the centuries. The deep sea is no longer a remote sanctuary. Industrial fishing, particularly bottom trawling, drags heavy nets across the seabed, scouring the sediment and shattering delicate artifacts that have rested undisturbed for millennia. These nets can reach depths once thought unreachable, and a single pass can erase a historical site forever. Similarly, the infrastructure of modern energy, like pipelines and communication cables, can slice through archaeological layers before anyone knows they are there. Perhaps the most insidious threat comes from a form of high-tech looting. Sophisticated side-scan sonar and remotely operated vehicles are not exclusive to archaeologists. Treasure hunters and commercial salvagers now possess the same tools, seeking shipwrecks not for knowledge but for profit. A sunken Roman vessel, its cargo of amphorae and potential artworks seen as a trove to be sold on the private market, represents a catastrophic loss of context. Once those objects are ripped from the seabed, their precise location, their relationship to each other, the sediment that cradled them, all that data vanishes. The story is destroyed to sell the pieces. This creates an urgent ethical dilemma at the heart of deep-sea archaeology. What do we do with these time capsules now that we can find them? The guiding principle emerging is one of in situ preservation, a phrase meaning to leave the site in its original place whenever possible. The goal is not to empty the deep sea of artifacts, but to protect them as a non-renewable cultural resource. Excavation is incredibly expensive, time-consuming, and always destructive. So, unless a site is in immediate danger from trawling or erosion, the best practice is often to document it meticulously with high-resolution photography and three-dimensional mapping, then monitor it over time. This allows the wreck to remain intact, its full story preserved for future generations of scientists who will have even better technologies to study it without causing harm. To enforce this principle, nations and international bodies are now pioneering a revolutionary concept: deep-sea marine protected areas specifically for cultural heritage. Imagine a designated zone in the open ocean, far from any coast, where these ancient shipwrecks are legally recognized as an underwater museum. Within these zones, bottom trawling, anchoring, and any intrusive activity would be prohibited. They become sanctuaries not just for marine life, but for human history. This shift in thinking is crucial. It acknowledges that these wrecks are not lost treasures to be claimed, but sacred pages in a shared human story, belonging to the world and to the future. Their true value lies not in gold, but in the light they shed on our collective journey across the blue. The ocean floor is now yielding its secrets faster than we can interpret them. For decades, maritime archaeologists dreamed of finding even one pristine wreck in the deep. Today, they face a different kind of challenge entirely, a problem born of their own success. With robotic surveys locating dozens of new sites each year, the field has undergone a seismic shift, moving from a scarcity of evidence to a staggering, almost overwhelming abundance. Each discovery is a data point, a single pixel in a vast, emerging picture of the ancient world. The new frontier is no longer just reaching the depths, but making sense of what we find there. How do you synthesize the story told by hundreds of shipwrecks and hundreds of thousands of artifacts scattered across an entire sea? The answer lies not in deeper diving, but in smarter thinking, powered by a suite of digital tools that are transforming archaeology into a science of patterns. The first step is simply knowing what you have. Traditional methods of cataloging with handwritten logs and two-dimensional sketches cannot scale to this new reality. Enter comprehensive digital databases. Every artifact from a 10-ton pile of ingots to a single olive pit is now photographed in high resolution, its precise three-dimensional location recorded with laser scanners. These records are tagged with metadata, its material, its likely origin, its date. This creates a searchable, global library of the deep, where a researcher in California can instantly call up every example of a specific amphora type found off the coast of Crete, comparing them side by side without ever getting on a boat. But the tools go far beyond cataloging. Three-dimensional modeling software allows for virtual reconstruction. A remotely operated vehicle can capture millions of data points of a wreck site, which a computer then stitches together into a perfect digital twin. An archaeologist can put on a virtual reality headset and walk through this model, examining the relationship between cargo and hull from every angle, taking measurements and testing theories about how the ship sank, all without disturbing a single grain of sediment. This digital preservation is permanent and perfect, a backup copy of history safe from the ravages of time or human interference. The most profound shift, however, comes from big data analysis. When you have information from hundreds of wrecks across 2,000 years, patterns emerge that are invisible at the scale of a single site. Advanced algorithms can analyze trade routes not as lines on a map, but as evolving networks. They can detect subtle shifts in cargo composition over centuries, revealing how economic priorities changed after a war or a political realignment. They can correlate ship construction techniques with specific regions and time periods, building a family tree of naval engineering. This data-driven approach turns anecdote into evidence. It allows historians to move from saying, "We found a ship that carried Greek pottery to Egypt," to stating, based on the analysis of 73 wrecks from the 4th century, there was a 42% increase in direct shipments of Aegean wine to the Nile Delta following a specific trade treaty. The problem of abundance, therefore, is really a promise. It is the promise of seeing the ancient Mediterranean not as a collection of isolated events, but as a dynamic, pulsating system, its rhythms and flows now quantifiable for the first time. The deep sea is giving us the data, and our digital tools are finally allowing us to listen to the full symphony. These digital models and data points do more than reconstruct trade, they resurrect an entire lost world. The deep sea time capsules are not just archaeological sites, they are environmental archives, offering scientists from fields far beyond history a chance to sample the ancient Mediterranean as it truly was. When a robotic arm retrieves a clump of sediment from around a 3,000-year-old amphora, it is not just collecting dirt, it is gathering a frozen moment in ecological time, packed with clues invisible to the naked eye. Within that sediment, scientists find a treasure trove of environmental data, pollen grains from long-vanished forests, tiny seeds from ancient crops, fragments of insect wings, and even the microscopic bones of fish or rodents that may have been on board. For a paleobotanist, a single seed or a handful of pollen can be revolutionary. Pollen is incredibly durable, and each grain is shaped like the plant it came from. By analyzing the pollen spectrum from a deep-sea wreck layer, scientists can reconstruct the vegetation landscape of the nearby coast at the exact time the ship sailed. They can tell if the hills around a Cretan harbor were covered in oak forests or had been cleared for olive groves. They can detect the presence of crops like wheat or barley, painting a picture of ancient agriculture. This data feeds directly into our understanding of paleoclimate. Certain plants are indicators of specific conditions, wet or dry, warm or cool. A shift in the pollen record around a series of wrecks from different centuries can reveal a period of drought that might have strained agricultural yields, potentially driving trade for foreign grain, or a period of unusual warmth that allowed vineyards to flourish in new regions. Even the insect parts tell a story. The remains of grain weevils or beetles that infest stored foodstuffs found in a ship's hold are not just signs of poor housekeeping. They are evidence of the length of the voyage, the storage conditions in the port of origin, and the interconnectedness of ecosystems as pests traveled across the sea with human cargo. But the most cutting-edge insights come from a level even deeper than the sediment, the genetic level. Advanced biomolecular archaeology can now extract ancient DNA from residues inside amphorae. In a jar that once held wine, scientists are not just looking for chemical traces of grapes, they are searching for the genetic signature of the specific vine cultivar. This can pinpoint the geographic origin of the wine with astonishing precision, tracing it to a particular valley in Greece or a hillside in Italy. Similarly, analysis of the resins used to seal the jars can identify the species of tree it came from, revealing ancient forestry practices and trade in raw materials. Even the ship itself becomes a genetic archive. The preserved hull timbers often bear the telltale tunnels of shipworms, the mollusks that bore into wood. By studying the ancient DNA of these shipworms, researchers can learn about the salinity and temperature of the water in different parts of the Mediterranean at the time, adding another layer to our climate models. This interdisciplinary dialogue transforms a shipwreck from a historical event into a holistic environmental snapshot. The botanist, the geneticist, and the climatologist all find their data in the same lump of deep-sea mud, working alongside the archaeologist. Together, they answer questions that no single field could tackle alone. What was the ecosystem that supported this trade network? How did climate shifts influence the rise and fall of maritime routes? How did the movement of people and goods reshape the very biology of the ancient world? The deep sea, once a void, is now a vibrant crossroad of sciences, each discovery a thread weaving a richer, more complete tapestry of our past. Yet for all its revelatory power, this deep-sea evidence demands a careful, critical eye. The silent testimony of a shipwreck is powerful, but it is not always simple to interpret. A single amphora resting on the abyssal plain is a thrilling discovery, yet it is not by itself a historical fact. It is a clue, one that requires context and caution to understand correctly. Scholars rightly remind us that the story being rewritten is not a simple replacement of one absolute truth with another, but a nuanced refinement of a complex picture. The first challenge lies in the very act of dating these sites. While dendrochronology can provide astonishing precision for a whole plank, that date marks the year the tree was felled, not necessarily the year the ship sailed. A vessel could have been in service for decades before its final voyage. Furthermore, a shipwreck is a collection of objects from different times. The cargo might be newer than the ship itself, or older personal items could have been on board for years. Establishing a single, definitive date for the moment of loss requires cross-referencing multiple lines of evidence, from pottery styles to radiocarbon dates on organic remains, a process that is both an art and a science. This complexity means that initial excitement over a find must always be tempered by meticulous analysis before it can firmly anchor a new point on our historical timeline. Equally important is the debate over what a deep-sea wreck actually represents. Finding a ship in the open basin is clear proof it was there, but not absolute proof of its intended route. Critics and cautious scholars pose a vital question. Could some of these vessels have been victims of circumstance rather than pioneers of choice? A coastal trader caught in a sudden, violent storm could have been blown far off course, its crew fighting a losing battle against the wind until their ship foundered in deep water they never meant to enter. In this scenario, the wreck's location does not map a commercial highway but a tragic accident. Disentangling intention from disaster is one of the great puzzles of maritime archaeology. Researchers look for patterns to find the signal in the noise. A single, isolated wreck in an otherwise empty stretch of sea could indeed be a storm-driven anomaly. But when surveys reveal multiple wrecks of similar age clustered along the same underwater corridor, the probability shifts dramatically. That repeated pattern points to a route, not a series of identical mishaps. The emerging map of deep-sea sites, with its growing clusters along efficient paths between ancient ports, strongly supports the interpretation of intentional sailing. Yet the caution remains essential, a guard against over-enthusiasm that ensures each new discovery is weighed with rigor. This balanced perspective extends to the scale of these operations. The discovery of a spectacular wreck like Uluburun rightfully captivates us, but it is vital to ask whether it represents common practice or a spectacular exception. Was it a royal dispatch, a one-of-a-kind mission carrying the treasure of a king, or was it simply a larger version of the merchant ships that plied the routes every season? The answer likely lies in the middle, in a graduated spectrum of maritime activity. There would have been routine, small-scale traders carrying local goods along familiar coasts. There would have been the ambitious, deep-water merchants moving bulk commodities on the open sea. And there would have been the rare, magnificent state-sponsored vessels like Uluburun. The deep-sea record is now beginning to reveal all these layers, from the modest cargoes to the grand shipments, allowing us to appreciate the full complexity of ancient maritime economies without reducing them to a single, simplistic narrative. This scholarly caution is not a barrier to understanding, it is the framework that makes the rewrite credible. By acknowledging the limitations and debates, the new timeline being written from the deep gains strength and durability, built not on a few spectacular finds, but on an accumulating body of evidence that can withstand critical scrutiny. The seafloor's library is vast, and we are only learning how to read its full story. The deep sea's evidence forces us to look at our oldest stories with new eyes. For centuries, the epic voyages described in Homer's Odyssey have been celebrated as brilliant poetry, but largely dismissed as historical fantasy. Scholars viewed Odysseus's 10-year journey through fantastical seas, past monsters and seductive goddesses, as a beautiful allegory for the human condition, not a record of real seafaring. The detailed descriptions of ships, storms, and star-guided navigation were seen as literary devices, the embellishments of a master storyteller weaving a tale for a land-bound audience. The traditional archaeological model, with its cautious coastal sailors, seemed to offer no foundation for such daring blue-water adventures, but the deep-sea discoveries from the Bronze Age are changing that perception in a profound way. We are now finding that the world Homer described, a world of interconnected kingdoms reached by sea, was not a poet's invention but a cultural memory. The Odyssey was an oral tradition passed down by bards for generations before being written down. Like all such traditions, it layers myth over a bedrock of lived experience. The deep sea wrecks provide that bedrock, When Homer describes Odysseus building a raft to leave the island of Calypso, he gives specific technical details. He speaks of felling trees, drilling holes with an auger, fitting planks closely together, and raising a mast. This is not vague fantasy. It is the language of a society intimately familiar with shipbuilding. More strikingly, Homer repeatedly references navigation by the stars. In one famous passage, the goddess Calypso advises Odysseus to keep the constellation of the Great Bear, which never sets, on his left hand as he sails eastward. This is a precise, workable navigational instruction for crossing the open Mediterranean. For a long time, historians read this and thought it was an anachronism, a detail from Homer's own later Iron Age inserted into a Bronze Age story. But the deep-sea evidence suggests otherwise. The shipwrecks from the late Bronze Age, like the one at Uluburun, prove that mariners from that exact era were undertaking voyages of the scale and distance described in the epics. They were sailing from the Aegean to the coasts of North Africa and the Levant, journeys that would have required exactly the kind of celestial navigation Homer describes. This does not mean we should search for a one-eyed giant or a witch who turns men into pigs on a sonar map. It means the poem's fundamental backdrop, a world knit together by capable, deep-water sailing, is authentic. The oral tradition preserved the feel of the sea, the knowledge of its dangers and its pathways, long after the palaces that launched those ships had fallen into ruin. Homer was not writing a manual, he was singing a memory. The monsters and miracles served the story, but the salt spray, the sturdy hull, and the guiding stars were inherited truths. This connection transforms the Odyssey from a purely mythical text into a cultural echo, a resonant artifact that carries within its verses the distant hum of Bronze Age engines crossing the open blue. It suggests that our greatest stories are often anchored in a reality we have only just begun to recover from the deep. This Mediterranean rewrite is not an isolated correction. It is a template, a powerful blueprint for rethinking human history on a global scale. For generations, the Mediterranean served as the textbook case for the cautious, late development of seafaring. Its timeline was considered settled, its story the model against which all others were measured. But if our foundational understanding of this intensely studied sea was so profoundly incomplete, what does that imply for the rest of the world's oceans, where deep-sea archaeology has barely even begun? The logical conclusion is staggering. We have likely underestimated ancient human mobility and connection across every major body of water on the planet. The deep-sea revolution in the Mediterranean provides both the method and the motivation to look elsewhere with entirely new eyes. Consider the vastness of the Indian Ocean, a maritime crossroads linking Africa, Arabia, India, and Southeast Asia for millennia. Historical texts and coastal archaeology speak of a thriving monsoon-driven trade network at least 2,000 years old. But what about before that? The same coastal bias that shaped Mediterranean history applies here. We have evidence of spices, pearls, and textiles moving, but the ships that carried them, and the true antiquity of direct, open water routes, remain a mystery hidden beneath the waves. The deep basins of the Indian Ocean could hold shipwrecks that push the origins of this interconnected world back centuries earlier, revealing voyages between ancient Harappa and Mesopotamia, or early Austronesian traders reaching Africa long before the accepted timelines. The promise is even more profound in the Pacific, the greatest ocean of all. The settlement of remote Oceania, the incredible dispersal of peoples across thousands of miles to islands like Hawaii, Rapa Nui, and Aotearoa, New Zealand, stands as one of humanity's greatest feats of navigation. We know they achieved it, but the deep Pacific floor is a virtually untouched archive of that expansion. Each voyage was a one-way journey into the unknown, and some vessels inevitably would have been lost far from any land. Finding even one such deep sea canoe preserved in the cold abyssal plains would be a discovery of monumental importance. It would give us the physical blueprint of their technology, the cargo they carried for colonization, and could potentially pinpoint the specific routes they followed. This is not about proving fantastical transoceanic contact theories, but about using hard evidence from the deep to calibrate the true scale and sophistication of known migrations. The Mediterranean example teaches us that the most direct evidence of long-distance voyaging does not lie on the shores people reached, but on the seabed along the routes they took to get there. Every ocean has its own deep water highways, its own equivalent of the route between Crete and Egypt. The robotic explorers and sonar mappers that rewrote the history of one inland sea are now poised to embark on a much grander project to illuminate the dark, silent chapters of a truly global human story written on the ocean floor. The tools that brought us this far are about to become exponentially more intelligent. The next wave of deep-sea archaeology will not just be about reaching the seabed, but about understanding it instantly, with a speed and intimacy we can barely conceive today. The key lies in artificial intelligence, not as a replacement for human curiosity, but as an amplifier of it. Picture the current process. A research vessel tows its sonar array, collecting terabytes of raw data that looks like a grainy, black and white image of the seafloor. Teams of experts then spend weeks, sometimes months, hunched over screens, scanning every pixel for the subtle signatures of a shipwreck or an artifact. It is painstaking, human-limited work. Now, imagine an AI system trained on thousands of known wreck sites. This system could process that same sonar data in real time as it is collected, flagging potential sites with a confidence percentage before the ship has even passed over them. It would learn to distinguish between a natural rock formation and a pile of amphorae, between a modern shipping container and a Bronze Age hull. This is not science fiction. Early prototypes are already being tested, learning to recognize the acoustic fingerprints of cultural heritage. The result is a radical acceleration of discovery, turning the search from a slow, methodical scan into a targeted hunt, freeing archaeologists to focus on interpretation rather than detection. But finding a site is only the beginning. The true challenge is mapping it, especially when it covers a large area or is broken into scattered debris. This is where the concept of swarm robotics enters the picture. Instead of deploying a single, expensive autonomous vehicle, future missions might release a coordinated fleet of dozens, even hundreds, of miniature AUVs. Each one would be no larger than a briefcase, communicating with its neighbors like a school of fish. They would fly in a pre-programmed formation, blanketing a massive swath of seafloor with sensors. One swarm could map an entire ancient harbor or a miles-long debris trail in a single dive, creating a unified, ultra-high-resolution, three-dimensional model in a fraction of the time it takes a single vehicle. Their small size and numbers also offer redundancy. If one unit fails, the swarm reconfigures and continues the mission. This approach transforms large-scale deep-sea survey from a major logistical undertaking into something more routine and comprehensive, allowing us to see not just individual shipwrecks, but the entire archaeological landscape of the deep. The final frontier of this technological leap is the most personal touch. For all our robotic precision, excavation has remained a visually guided process. An operator on the surface watches a video feed and manipulates joysticks to control a robotic arm thousands of feet below. It is like performing surgery while looking through a straw, with no physical sense of the object being handled. The next generation aims to restore that crucial sense of touch through haptic feedback systems. Imagine an archaeologist wearing a specialized glove on the surface. As the subsea robot's arm reaches out and makes contact with a 3,000-year-old ceramic jar, sensors in its gripper transmit force and texture data back to the surface glove. The archaeologist would feel the subtle resistance of the object, the grit of the sediment, the delicate weight of the artifact in their own hand. This technology, already in development for remote surgery and hazardous material handling, would allow for incredibly delicate manipulation. An operator could feel if a grip is too tight, sense if an object is fragile or stuck, and perform the nuanced tasks of excavation with a conservator's gentle intuition. It closes the vast physical distance between the human mind and the historical object, making deep-sea archaeology not just a remote observation, but a tactile experience. Together, these tools promise a future where the deep sea is no longer a dark, forbidding archive, but an interactive library. I will point the way. Robotic swarms will illuminate the pages, and haptic interfaces will let us turn them with care. This is not about removing the human element from discovery, but about deepening it. By outsourcing the repetitive tasks of searching and mapping to intelligent machines, and by restoring the lost sense of touch, we free archaeologists to do what only humans can do, to ask profound questions, to weave narratives from fragments, and to feel, across the millennia, the tangible connection to those who sailed into the blue. The future of understanding our past lies in this symbiotic partnership, where human curiosity is empowered by silicon intelligence and robotic grace. The technological leap that allows us to ask these questions is also what makes answering them a tangible possibility for the first time. We stand at the edge of a new frontier, armed with tools that can finally interrogate the deepest silences of the sea. The greatest discoveries are no longer just about finding more of what we already know, but about uncovering entire categories of history we have never seen. The big, tantalizing mysteries are now within our reach, waiting for the right sonar ping or robotic camera to bring them into the light. Consider the warship. We have found the peaceful merchants, the bulk carriers of the ancient world, resting with their cargoes of wine and copper. But what of the vessels built for power and conflict? Historical texts speak of mighty fleets, of sea battles that decided the fate of empires. Yet we have never laid eyes on a perfectly preserved Minoan or Phoenician warship from the deep. What would such a discovery reveal? Its construction would be a masterclass in martial engineering, designed not for cargo capacity but for speed and ramming force. We might find the actual bronze ram, a weapon known only from sculptures and descriptions, still attached to its wooden prow. Inside, we could uncover the personal arms of the crew, their arrangements for battle, and perhaps even clues to the nature of ancient naval warfare far from any shore. Finding a deep-sea warship would do more than satisfy historical curiosity. It would prove that dominion over the blue highways was contested, that control of these open water routes was worth fighting for, adding a layer of political and military strategy to our map of ancient connectivity. Then there is the question of time itself and how much further back this story truly goes. The Dokos wreck proved organized open water trade existed over 4,000 years ago. But what about the pioneers, the very first people to push beyond the sight of land? Are there even earlier Neolithic deep-sea crossings waiting to be discovered? Imagine a simple log canoe or a reed boat carrying a family and their few belongings, venturing across a strait deeper and wider than we thought possible for that era. Finding such a site in the deep would be the ultimate challenge, as these organic vessels leave faint traces. Yet if one were preserved in an anoxic basin, it would rewrite the opening chapter of human migration in the Mediterranean entirely. It would suggest that the drive to explore and connect by water is a fundamental, ancient part of our story, not a later development of complex civilizations. This search pushes archaeology into the realm of paleoanthropology, asking not just about trade, but about the spread of people, ideas, and technologies in the very dawn of settled life. Beyond migration and conflict, there are quieter yet equally profound mysteries of daily life on the open sea. The deep basins may hold evidence of economic activities we have never considered. Could we find proof of deliberate deep water fishing in antiquity? Ancient writers sometimes mention large, prized fish caught far from shore. A wreck site that included specialized fishing gear, like deep water nets or lines with stone weights, alongside preserved fish bones from pelagic species, would reveal an entire offshore industry. It would show that ancient communities did not just use the sea as a road, but harvested its depths for sustenance, requiring another layer of skill and courage. Similarly, might there be evidence of deep water resource extraction? The pursuit of rare materials could have driven early exploration. Sponges, precious red coral, or even mineral nodules could have been targets. A site showing tools for collection and raw materials in mid-transport would unveil a hidden economy of the abyss, showing that human ingenuity sought value in every part of the marine world. These are not just gaps in a historical checklist. They represent entire dimensions of the ancient human experience that currently exist only in theory or faint illusion. The paradigm shift powered by submersibles and artificial intelligence has moved these questions from the realm of pure speculation into the domain of actionable science. We are no longer wondering if such things exist. We are now capable of systematically looking for them. Each unanswered question is a beacon, guiding the next generation of dives and surveys. The map of the ancient deep is being drawn, and its most exciting regions are still labeled terra incognita. The robots are our scouts, and their next transmission from the darkness could be the one that shows us a silhouette we have never seen before, a shape that forces us to once again reconsider what we know about courage, curiosity, and connection in the ancient world. The true revolution lies not in any single discovery, but in a fundamental shift in perspective. Deep-sea submersibles and their robotic partners have transformed the very nature of underwater archaeology. We are no longer limited to studying the scattered fragments that washed ashore. Instead, we have gained the ability to systematically explore the ancient world's maritime superhighways, the direct routes that were its lifeblood. This is not merely about finding older shipwrecks, though we are certainly doing that. It is about reconstructing an entire system of human endeavor that was literally invisible to us just a generation ago. Each dive into the abyss retrieves more than artifacts. It retrieves context, revealing a portrait of our ancestors that is far more daring, interconnected, and technologically adept than our history books ever allowed. The timeline of Mediterranean seafaring is not just being adjusted by a few centuries. It is being pushed back and filled with breathtaking, unprecedented detail. We now have dates precise to a single year, cargo manifests written in molecular residues, and engineering blueprints preserved in cold silt. This granular evidence allows us to write a new kind of history, one that moves from broad speculation to specific understanding. We can trace an individual olive from a specific grove, follow it onto a ship built from timber felled in a particular forest, and map its journey across the open sea until its resting place in the deep. This is history written from the ocean floor up, a bottom-up narrative built from countless data points recovered from the darkness. It rewrites chapters not by erasing the old story, but by illuminating the vast, missing sections that were always there, waiting in the silent library of the deep. The most profound lesson may be a humbling one. For centuries, we interpreted the past through the lens of our own limitations, assuming that what we could easily find on land and in shallow water was the full picture. The deep sea has taught us that the most direct evidence of human ambition often lies in the hardest places to reach. It reminds us that our ancestors consistently defied the boundaries we later imposed upon them, guided by stars we still recognize across a sea whose depths we are only now beginning to truly know.